When adapting a 4-wire receptacle to a 3-wire dryer, there are a couple of approaches, although one is more highly recommended than the other. The preferred method, especially in the context of the 2002 National Electrical Code, involves specific connections to ensure safety and proper functionality. You'll need a 3-wire dryer cord that is actually a 4-prong cord, a 4-wire receptacle, which is a 14-50-hour configuration, and wire nuts for secure connections. The first step is to connect the bare copper ground wire coming from the dryer cord to the green screw located on the 4-wire receptacle. This establishes a solid ground connection. Next, connect the white neutral wire from the dryer cord to the silver screw on the receptacle. This provides the necessary neutral return path. Then connect the 2 hot wires, typically black and red, from the dryer cord to the 2 brass screws on the receptacle. These supply the electrical power to the dryer. Finally, cap off the 4th wire from the dryer cord, which is often blue in color, using a wire nut. This wire is not used in this configuration and needs to be safely insulated. An alternative method exists, however. It is less preferred and might not align with current electrical standards or best practices. This method also necessitates the following materials: a 3-wire dryer cord that is actually a 4-prong cord, a 4-wire receptacle of the 14-50-hour type, wire nuts, and electrical tape. Start by connecting the bare copper ground wire from the dryer cord to the green screw on the receptacle, just as in the preferred method. Then, connect the white neutral wire from the dryer cord to the silver screw in the receptacle, again mirroring the preferred method. Next, connect one of the hot wires, either black or red, from the dryer cord to one of the brass screws on the receptacle. This is where this method begins to diverge. Then, connect the 4th wire, the one typically blue, from the dryer cord to the other brass screw on the receptacle. This step is a key difference and a potential point of concern. Finally, wrap electrical tape around the remaining hot wire, either black or red, to prevent it from touching anything. This is a crucial safety measure but also highlights the less than ideal nature of this method. It is extremely important to always turn off the power at the circuit breaker before starting any electrical work. Employ wire nuts that are properly rated for the size and type of wire being used to guarantee secure and reliable connections. Ensure that all connections are consistently tight and secure. Neither of these methods is explicitly described in the 2002 National Electrical Code. However, they are designed to meet the general requirements for grounding and electrical safety. Regardless, it is always best practice to consult with local electrical authorities to confirm compliance with any specific regulations or interpretations in effect in the jurisdiction where the work is being performed. Proper grounding is absolutely essential for electrical safety. It provides a path for fault current to return to the source, tripping the circuit breaker and preventing electrical shock. The green screw on the receptacle is specifically designated for the ground wire. The neutral wire provides a return path for the normal flow of current. It is typically identified by its white or grey color and connects to the silver screw on the receptacle. Hot wires carry the electrical current from the source to the appliance. They are usually black or red and connect to the brass screws in the receptacle. Wire nuts are used to safely and securely connect 2 or more wires together. It is important to select the correct size and type of wire nut for the wires being joined. Electrical tape is used to insulate and protect electrical connections. It should be applied tightly and neatly to prevent moisture and corrosion. The National Electrical Code, or NEC, is a set of standards for safe electrical installation. It is updated every 3 years and is adopted by most jurisdictions in the United States. Local electrical codes may have additional requirements or interpretations of the NEC. It is essential to consult with local authorities to ensure compliance. Working with electricity can be dangerous. It is important to take precautions to protect yourself from electrical shock. Always turn off the power before working on any electrical wiring. Wear appropriate personal protective equipment, such as gloves and safety glasses. If you are not comfortable working with electricity, hire a qualified electrician. When connecting wires, make sure to strip the insulation back far enough to expose enough conductor for a secure connection, but not so far that bare wire is exposed outside the wire nut. Twist the wires together tightly before applying the wire nut. This will ensure a good electrical connection and prevent the wires from coming loose. After applying the wire nut, give it a gentle tug to make sure it is secure. If the wire nut comes off easily, it is not properly installed and needs to be replaced. When using electrical tape, wrap it tightly and neatly around the connection. Overlap each layer of tape to create a waterproof seal. Avoid stretching the tape too much, as this can weaken the adhesive. If you are working in a damp or wet environment, use waterproof wire nuts and electrical tape. This will help to prevent corrosion and electrical shock. When troubleshooting electrical problems, always start by checking the circuit breaker. Make sure the breaker is not tripped and that it is properly sized for the circuit. Use a multimeter to test for voltage and continuity. This can help you to identify the source of the problem. If you are not comfortable troubleshooting electrical problems, hire a qualified electrician. Proper labeling of electrical panels and circuits is essential for safety and convenience. Label each circuit breaker with a clear description of the loads it serves. This will make it easier to identify and shut off the power to specific circuits when needed. Use a permanent marker or label maker to create clear and legible labels. Keep the labels up to date as circuits are added or changed. Consider creating a circuit directory that lists all of the circuits in the panel and their corresponding labels. This will make it even easier to find the circuit you are looking for. Regularly inspect electrical panels and wiring for signs of damage or deterioration. Look for loose wires, corroded connections, cracked insulation, and other potential hazards. If you find any problems, have them repaired by a qualified electrician. Electrical safety is everyone's responsibility. By following these tips, you can help to prevent electrical accidents and ensure the safety of yourself and others. The size of the circuit breaker and wiring depends on the amperage of the dryer. Refer to the dryer's nameplate for its amperage rating. Use the appropriate National Electrical Code table, such as Table 310.15b16, to determine the correct wire size for the amperage. Typically, for a dry circuit, 10 American wire gauge or 8 American wire gauge copper wire is used, protected by a 30 amp or 40 amp circuit breaker respectively, but always verify based on the dryer's specifications and local codes. The 4-wire system is safer because it separates the neutral and ground conductors. In older 3-wire systems, the neutral conductor also served as the ground, which could create a shock hazard if there was a fault. The 4-wire system provides a dedicated ground path, reducing the risk of electrical shock. When retrofitting an older 3-wire dryer circuit to a 4-wire system, it is essential to properly disconnect the bonding jumper at the dryer. This bonding jumper connects the neutral terminal to the dryer's metal frame. In a 4-wire system, the dryer frame should be grounded only through the dedicated ground wire. If the bonding jumper is not removed, it can create a parallel path for neutral current, which can lead to nuisance tripping of the circuit breaker and increase the risk of electrical shock. Always consult the dryer's installation instructions for specific guidance on removing the bonding jumper. Use a torque screwdriver to tighten the screws in the receptacle and circuit breaker. Proper torque ensures a secure connection and prevents overheating. Refer to the manufacturer's specifications for the correct torque values. Over-tightening can damage the terminals, while under-tightening can lead to loose connections. When installing a new dryer circuit, consider using arc fault circuit interrupter, or SI protection. SIs are designed to detect arc faults, which are a common cause of electrical fires. SIs can provide an additional layer of safety by tripping the circuit breaker when an arc fault is detected. Some jurisdictions now require a SI protection for all new dryer circuits. Before starting any electrical work, use a non-contact voltage tester to verify that the power is off. These testers can detect the presence of voltage without making direct contact with the wires. This is a quick and easy way to ensure that the circuit is de-energized. However, it is still important to use a multimeter to confirm that there is no voltage present before touching any wires. When running new wiring, use cable staples to secure the cable to the framing. Space the staples according to the National Electrical Code requirements, typically every 12 inches. Avoid overdriving the staples, as this can damage the cable insulation. Make sure the staples are not pinching the cable. When connecting the wires to the circuit breaker, make sure to land them on the correct terminals. The neutral wire should be connected to the neutral bus bar, and the hot wires should be connected to the breaker terminals. Tighten the screws on the breaker terminals to the correct torque. When installing a new receptacle, use a level to ensure that it is installed straight. This will give the installation a professional look. Use shims if necessary to correct any imperfections in the wall surface. When replacing an old receptacle, check the condition of the box. If the box is damaged or corroded, replace it with a new one. Make sure the new box is properly grounded. When working with aluminum wiring, use connectors and devices that are specifically designed for aluminum. Aluminum wiring expands and contracts more than copper wiring, which can lead to loose connections if not properly installed. Use an antioxidant compound on the aluminum wiring before making connections. When running wiring through metal studs, use grommets to protect the wiring from abrasion. Metal studs can have sharp edges that can damage the cable insulation. Grommets provide a smooth, protective surface for the wiring to pass through. When installing a dryer vent, use rigid metal ductwork. Flexible ductwork can restrict airflow and create a fire hazard. Make sure the vent is properly sealed to prevent moisture and lint from entering the wall cavity. The vent should terminate outside the building, away from windows and doors. Regularly clean the dryer vent to remove lint buildup. Lint buildup can restrict airflow and create a fire hazard. Clean the vent at least once a year, or more often if you use your dryer frequently. Use a lint brush to clean the lint trap after each load. When purchasing a new dryer, consider a model with a moisture sensor. Moisture sensors can automatically adjust the drying time based on the moisture level of the clothes. This can save energy and prevent overdrying. Choose a dryer that is the right size for your needs. A dryer that is too small will require more loads, while a dryer that is too large will waste energy. Consider the energy efficiency of the dryer when making your purchase. Look for models that are ENERGY STAR certified. Always follow the manufacturer's instructions when installing and operating your dryer. This will ensure safe and efficient operation. If you have any questions about dryer installation or wiring, consult a qualified electrician. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Electrical work can be dangerous, so it is important to take precautions to protect yourself and others. Never work on electrical wiring unless you are qualified and comfortable doing so. Always turn off the power before working on any electrical wiring. Use appropriate personal protective equipment, such as gloves and safety glasses. If you are not sure how to do something, ask for help from a qualified electrician. By following these safety tips, you can help to prevent electrical accidents and ensure the safety of yourself and others.